Hi, this is Dana Gardner, Principal Analyst at Inter Arbor Solutions, and you're listening to BriefingsDirect. The burgeoning use of APIs across cloud-native computing and digital business ecosystems has rapidly accelerated due to the COVID-19 pandemic. Enterprises have had to scramble to develop and procure digital supply chains and new business-to-business processes. They've also extended their business perimeters to at-home workers, as well as to reach more purely online end users and customers. In doing so, they may have been given short shrift to cybersecurity vulnerabilities inherent in the expanding use of APIs. Stay with us now for part 2 in our series that explores how APIs, microservices, and cloud-native computing require new levels of defense and resiliency. To learn more about the latest innovations for making APIs more understood, trusted, and robust, please join me now in welcoming our special guest. We're here again with Jyoti Bansal. He's Chief Executive Officer and co-founder at Traceable AI. Welcome back, Jyoti.
Great to be here again, Dana.
You know, in our last discussion, we learned about how the exploding use of cloud-native apps and APIs has opened a new threat vector. And as a serial startup founder in Silicon Valley, as well as a tech visionary, what are your insights and experiences telling you about the need for identifying and mitigating API risks? How is protecting APIs different from past threats?
It's a good question. I think the protecting APIs is different in one fundamental way, that it's all about software and developers now. APIs are created so that you could innovate fast. You want to empower your developers to move fast and use DevOps, use CI/CD, use microservices, use serverless. You want them to go and break the code into smaller and smaller pieces and connect those smaller pieces through APIs, either internally or externally or through third party. And that's the future of how software innovation will be done. And now it's like the way you have to secure these is by not slowing down the developers. Because the whole point of APIs is that you want to this kind of unleash the next level of developer innovation and the developer velocity. And so the securing them is good. It has to be different, that you have to do without hurting developers, and in many ways by involving them into the API security process.
How has the pandemic affected the development process? Are people working from home? Are they scrumming all virtually? Is there a shift left that can happen through a distributed workforce? How have you seen the development function adjust in the past year or so?
The software development function in the past year has become almost completely work from home, distributed. The world of software engineering was already on that path, that we were becoming more and more global and more distributed, and most software engineering teams will have some distributed global element to it. But the pandemic forced it to be the de facto way to do things. So now it's like, everything that the software engineers and software developers will do in their process is completely going through home. It's like most of the times you don't even use a VPN anymore. Like everything in the cloud, you have your source code in the cloud, you have your build systems in the cloud, you have your CI/CD processes in the cloud, and your infrastructure where you're deploying is also in a cloud. So you don't really go through VPNs and your traditional way of doing things. And it's a very open kind of, connect from everywhere from a software development process kind of world now.
So, Jyoti, how can the next round of what software engineers and solution architects do with APIs be made safer? How are we going to help bring to these developers more of the insights and information that they can use to be thinking about security in ways that they perhaps didn't before?
The most important thing is to really have the understanding and insights. I think the fundamental problem that we always start with in any of these things is that people don't even know what APIs are there. People don't know what APIs have a potential security risk into them. What people don't know what APIs could be used by attackers in bad ways. And so what you want to do is to create a lot of transparency around this. I like to call it like, just turning on the lights. In many ways, the developers are operating in the dark, like, they're building all these APIs, and you have normally if you think of these days, like, you will have one software dev team is like maybe 5 to 10 engineers. You have you have organizations with, let's say you have 200 engineers or 500 engineers, and they're all working on their piece, which is normally one or two microservices, and they're all exposing different APIs. And so it's very hard for them to understand, not just the picture of their own stuff, but the bigger out picture across all the engineering teams in their company and all the APIs and microservices they're building. They really have no idea, right? So it's to me, the first thing is you have to turn on these lights, that everyone knows what's going on. You're not operating in the dark. These are all my APIs. These are the APIs that talk to these other APIs. These are the different microservices, what change, how the data flows between them. And just having a real-time view of it is probably the number one thing. And we like to call it almost like a Google traffic map kind of view, where you can see this is how all the traffic is flowing, and this is where the red lights are, and this is how things connect, and this is where the different highways of data go from one place to another, and all of that. So you need to start with that. And that becomes a foundation for developers to become much more aware and conscious about how to design the APIs in a more secure way.
And if developers are only now beginning to get that information that's required at the scale that's required, and we can see that API security is a bit of a different beast, why is it that we need a new solution? Why don't the older solutions like web application firewalls or legacy security approaches fit the bill? Why do we need something different?
Yeah, because they were not really designed ever to understand APIs and secure the APIs. If you look at a web application firewall, it was designed to protect your system against the attacks that people will do on the legacy web apps, like a SQL injection, right? So, normally a web app firewall will look at if you have a form on your website that takes a field where someone can type a SQL kind of query and then use that to steal some data from it, right? And those web application firewalls will do those kind of things, but that's not how attackers will try to steal data from APIs. They are completely different kind of attacks that are happening. So most of the web application firewalls are okay for the legacy approaches of the legacy attacks also, even though they had challenges even with the legacy attacks in terms of how to scale and how to make it easy and simple. When it comes to APIs, they really don't have any kind of a solution to secure these.
In our last discussion, Jody, you mentioned how the people on whose shoulders the burden for API security falls are typically the application security folks. They've probably been looking at point solutions or patchers or spot types of affairs. But it sounds to me like traceable AI is a bit more of a horizontal or one-size-fits-all solution approach. How does that solution approach work, and how is it better able to attack the vulnerabilities here than some other spot application firewall, for example?
So the approach that we take at Traceable is, a bit of a platform approach to application security. So we think of application security starts with securing two parts of your app. One is the APIs that your apps are exposing, and APIs could be internal APIs, external APIs, third-party APIs. And second are your clients that you build on these APIs yourself. Could be a web application client, could be a mobile application client that you're building on those. So you have to secure those as well, right? So, but they're all fundamentally built on these days on top of the same APIs, that you're exposing out for other kind of clients, etc. Right? And when we look at now securing it, we think of in a very classic way. We think security is still about the same, which is you start by understanding and taking inventory of everything. Is what are all the things that are there. Second thing you look at now, protecting those things. And third thing you look at now is to do it more proactively. So instead of protecting them, can you go and fix things at the time of when the problem was created, right? And now, so our solution is designed as one end-to-end comprehensive platform for application security that can do all of these three things. All of these three things have to be done in a very different way, though, compared to any kind of the legacy web application firewalls or legacy RASP kind of solutions that the app security teams use. We take a very different approach. Our fundamental approach is around building this layer of tracing and instrumentation. And we make this tracing and instrumentation extremely easy, which is really about these very lightweight agents that we provide. You have to take our agent, and we have agents that will run into different programming environments like, Java and .NET and PHP and Node.js and Python, or agents that you could also put on your application proxies or your Kubernetes clusters. And in just a few minutes, you can install our agent. You don't have to do any work. It's just a minute. You just install the agent. And we will start instrumenting your runtime application code automatically and start tracing everything that is happening through them. So the first thing we will do, like once you put your agent in just a minute or two, we'll start drawing based on your real-time traffic that's going through those, the picture of everything. That these are your APIs in your system. These are the all the APIs that are external. These are all your internal microservices. These are all the internal API endpoints on each of the microservices. This is how the data flows between one microservice to second microservice to third. What are the third-party APIs you're invoking? What are the third-party systems you're invoking? And we'll draw that Google traffic map kind of picture in just a matter of minutes. Like this is how everything flows in your system, right? So that ability to understand and trace is really the fundamental first part, which is very different than any kind of legacy WAF or RASP app security kind of approaches that are out there, right? But now that once we kind of understand it all, then the second part starts in our system, which is creating a behavioral learning model around usage of your APIs and applications. Like which users are accessing what APIs, which users are passing what data into it, what is the normal sequence of API calls or clicks in the web application that the users would do, what internal microservices are invoked by every API, what pieces of data are being transferred, what volume of data is being transferred. All of that, we are bringing a very powerful machine learning model around it, where we learn that this is the sort of a n-dimensional behavioral model around everything that is happening. So once that model is built, which we could start and there is so much traffic that's going on that it doesn't take us time to build out a pretty accurate model, right? Now, every single call that is happening after that, we are comparing against the normal behavioral model. So we'll say, normally, when people call this API, they ask for data for one user. But suddenly, there's an API call for the same API that someone is asking data for 100,000 users, right? So now you will start, we'll flag that there is something anomalous around it, and then we'll start with going with a scoring mechanism where we can figure out what kind of attack someone is trying to do. Are they trying to steal data? And then we can create a remediation mechanism around either the blocking that user, block that particular way of invoking that API. Maybe alerting your engineering team to fix a bug in there, right? So that's really a very different approach that, most of the traditional WAF kind of approaches are very rule-based. Like you will define these rule sets and, with the regular expressions and expression matching around we don't do much of that. For us, it's all about learning the behavioral models through our ML and understanding whenever something is different and seems, different in a bad way, we can help you react to all this.
Yeah, it sounds very powerful and with a lot of potential applications. Now, you're a bit of a serial founder and startup force, having been involved with App Dynamics and Harness, and we talked about that in our first podcast. But one of the things that I've heard you talk about as a business person, as a founder, is that you need to think big. And I've also heard you say that we want to be able to protect every line of code in the world. And that's certainly thinking big. How do we take what you just described and extrapolate that to protecting every line of code in the world? Why is your model powerful enough to do that?
When we started Traceable, that's the mission we set, because that is, I do think we have to think big because that is a big problem. If I fast forward, say 10 years from now, the whole world is running on software. Everything we do is this interconnected software systems everywhere, right? And I just find it hard to imagine, why shouldn't we secure every piece of that software then? If the whole world is going to run on softwares, we have to make sure that every line of that code is secure. And the way we look at how do you make that happen, that every line of code is secure, is by doing a few fundamental things, which are hard to do, but in concept, they are simple. Can we watch every line of code when it runs in a runtime environment? It's you have, said, engineer wrote 1,000 lines of code and it's out there now and it's running. Can we watch when the code is running? So that's where the instrumentation and the tracing part comes in, where that the code is being watched on how it is run. So that's really the first part, right? The second part is can we learn what is the normal behavior of how that code was supposed to run and what did the developer intended when they wrote the code on how this code was supposed to run? And if we can learn it, that's really the second part. Now, the third thing is now if you see anything abnormal, you flag it or you block it or you do something about it, right? I almost think of I would imagine the world that if the world has trillions and trillions and trillions of lines of code and that's how we operate, every single line of code in the world out there should have this safety net built around it, that someone is watching how the code is used. We are learning what is the normal developer intent of that code was. And then if some attacker, hacker, malicious person is trying to use the code in a unintended way, you just stop it. That to me is like a no-brainer if we can make it possible and feasible from a technology perspective, right? So that's the mission we are on Traceable. Like, can we really make it possible and feasible to make this happen?
And Jody, one of the things that's implied in what we've been talking about that we haven't necessarily addressed is that the volume of data and the speed at which it's being generated and the requirement of being able to analyze fast in order to stop a breach or a vulnerability before it does much damage, all of that amounts to not being in a human scale, right? You can't do this with spreadsheets and sticky notes on a whiteboard. Are we just so far into AI and machine learning that we take it for granted that there's going to be a high level of automation here and that machines are basically going to be very important, if not central, to being able to manage and secure software?
I would 100% agree. It's in some ways like we have to use machines to protect against it. It's just the amount of data and the volume of things is so high. You can't really have a human, a SOC person, sitting looking at screens and trying to figure out that this thing is wrong. But that's where the challenge is. Like if you look at the legacy WAFs and all kind of the legacy approaches that don't use the right kind of ML and AI, it's the rules create so many false positives. Like every application security, product security kind of teams you talk to, they say we use these WAFs and the legacy approaches to app security, and we define these rule sets to define like these IPs are bad and these expressions are bad and all of this stuff, and it creates so much false positive and so much really junk alerts that they're drowned in those as humans. And that is really the challenge. Like, now if you take it to the APIs where the attack vector has been more complicated and, it's really not possible for humans to kind of go through this. Like you have to build a very powerful layer of learning and intelligence to figure it out. The great thing is that it is possible now. The ML and AI is to the point where you can build the right algorithms to learn the behaviors of how applications and APIs are used and how data flows through them and kind of use that to figure out abnormal usage behaviors and stop them. It is quite possible, and that's really the approach that we are trying to bring to the market.
Okay, let's think now about the human side of this. We've talked about technology quite a bit. If humans can't necessarily get into the weeds and deal with the complexity and scale, what is the right role for people? How do you oversee such a platform and a horizontal capabilities you're describing? So do we need a new class, a new persona, someone whose function is a data scientist for security of APIs, or does this fit into a more traditional security management approach?
Yeah, I don't think you need data scientists for APIs. That's the job of products like Traceable, that, we can do the data science and convert it into very actionable things from it. Instead of you need data scientists for APIs, right? So that's the technology, like Traceable itself could be the data scientist inside it. But what is needed from the people side is sort of this, I would say, the right model of organizing your teams. You hear the word DevSecOps, and I do think that kind of model is really, really needed. The core of DevSecOps is that you have your SecOps teams, traditional SecOps teams. They became much more developer and code and API aware and understands that. And your developer teams, they became much more security aware than they have been, right? So both sides have to come together and kind of bridge that gap, right? What we had was that the developers didn't care about security, and the security people didn't really care about code and APIs. They cared about networks and infrastructures and servers, and because that's where they spend most of their time trying to secure. But to really, from an organizational people perspective, we really need to bridge that part from both sides. And we'll look at also like creating this level of transparency and visibility by understanding what code is there and what APIs are there and which ones have security challenges and which ones are not. And you give that data to developers to go and fix it, and you give that data to your security ops teams to manage risk and manage your compliance and all kind of the responsibilities that they have. That helps bridge that gap as well.
And so we've traditionally had some cultural silos, developer silo, and then a security silo, and they haven't always spoken the same language, never mind been working hand in hand. It does sound to me, however, that the data and analytics that are generated from a traceable AI type solution can actually bind these cultures together. Is that how you see it, the output of your tool?
Exactly. That's how we think of it. Think of I'll give you one example of this new pattern of exposing data through something called GraphQL. It's like a API technology, which is like very powerful because you can expose your data into GraphQL where different consumers could write API queries to grab data, right? Becoming a very common pattern. Most developers who are writing these GraphQL APIs, they don't understand the security implications of it. They write the API and they don't understand okay, if I don't put the right kind of checks here, someone can go and attack them. But the challenge is on the other side, the most security ops people, they don't understand how GraphQL APIs work or even what they are even, right? So now we have a fundamental gap on both sides. So what we look at a product like Traceable helps bridge that gap by you put us there, we'll tell you, okay, these are your APIs and these are your GraphQL APIs and these are where the security vulnerabilities and these are. And this is where the sensitive data could potentially be stolen. And we will also tell you if there is an attack happening, we will also tell you that this is someone is trying to steal data from it that we stopped and we prevented. Now, once you have the data, the developers start seeing the data and they become much more security conscious because they see it in a dashboard that they build the GraphQL APIs and which has these 10 security vulnerabilities and these few attacks that are happening. And now you look at your SecOps team, they look at the same dashboard now. And they are looking at, okay, these are the APIs with this GraphQL, and these are the patterns with, by which attackers and hackers are trying to exploit them. So just having that common shared sense of data and a shared dashboard between the developers and the SecOps teams, it creates that kind of the visibility and the shared language on both sides for sure.
All right. I'd like to address the issue of the timing of your solution and your entry into the market. It seems to me that we have sort of a level of trust when it comes to the use of APIs, and that if what you've predicted with the vulnerabilities becomes exploited, or people don't put in the processes to create robust APIs on their own, that trust could be eroded, which could be very serious. So is there sort of a race to make sure that we can put in the solutions that keep APIs trustworthy before that trust gets eroded? And how do you propose to do that? And why is the timing essential?
In terms of timing, I do think we are in this kind of the middle of this API explosion right now. And we are not early enough that people in most of the times, unfortunately, when people adopt a new technology, they think about operational elements from security and performance and scalability a little bit later, once they start running into those problems and start challenging them. You wish that when people are designing things from very first day, they would think about all aspects of security and performance and scalability and all of those things, right? But normally people start, when they start seeing the challenges, they react in many ways. So we are at that time where people have seen the challenges that comes with API security and the threat vectors that that are being opened through APIs, etc. Right? So I do think that the timing is right, that the market and the security teams are understanding the need of it. People have seen some of the pains. We had some very high-profile attacks that have happened in the industry. Where attackers stole data through APIs and improperly secured APIs, etc. So from that, we think is a good time to bring a good solution in the market that can address this. I also think the adoption of CI/CD and DevOps is happening at such a rapid pace that API security and securing these cloud-native microservice architectures, that's starting to become a major bottleneck in that. As in the last discussion we talked about, I'm also founder of this company Harness, which is a very leading CI/CD platform in the market. And when we look at a lot of our customers, when we talk about what is the blocker in their adoption of CI/CD, or what is their blocker in adoption of moving to a public cloud or using to more microservices or more serverless architectures, they all want to do because they have the pressure to move faster and faster as a business. Concerns around application security, securing these cloud native applications, securing the APIs they're exposing are a big part of the blocker. So now it's starting to become a big business impact that it's starting to reduce their ability to move fast. It's starting to impact the velocity. So it's kind of strange, like, that you want to secure the APIs and secure everything so that you have risk mitigation and you have the data protection, you have all of those things, right, that your users would want. But there is other side of it, like, if you can't figure that out, you really won't have an option other than to slow down velocity and slow down adoption of cloud native architectures and DevOps and microservices, which has a huge business financial impact in a different way. So you really have to solve this problem. There's no other solution, no other way out.
All right, I'd like to revisit the concept of traceable AI as a horizontal platform capability and the progression. Once you've established those models and you're using that data and you're refining, even in a very complex and rapid environment, the analytics, what are the sort of use cases and progression of use cases that you see most likely for traceable? What's sort of the low-lying fruit? And once you've established that, where do you see this horizontal analytics of code generation and production going?
There's definitely a progression to it. The first starting low-lying fruit is to tell someone that you have a API that is risky, that this API has improper authentication into it, or this API is exposing PI data, but it doesn't have the right authorization control inside it. That becomes the first low-lying fruit that, you put us in your environment. We look at some of the traffic, and our learning models will tell you very quickly that you have these challenges. And what we do is we make it very simple from our product that you can open a Jira ticket for a developer to go and kind of work on fixing that, right? So that's the first level. The second level now is like, as you go in, the progression is about protecting those. So some of these things you may not be able to fix. Some of these things you may not even have a very, let's say, a low-hanging fruit vulnerability, but there might be very sophisticated business logic abuse that a hacker is trying to do, right? So we would start to, once our models are built out and we're comparing how people are using it, we create a very simple model of flagging this by attributing the bad behavior to a user. What we call a threat actor. Like, threat actor could be a bot. It could be a particular, authenticated user. It could be unauthenticated user. It could be a sequence of IPs. It could be, somewhere, some threat actor that is trying to do something that is not normal behavior. And we see patterns of abuse around data theft or something that are happening around it. We can alert you, we can block you. So that becomes the second part of the progression. The third part in that progression after that becomes, how do you be more proactive about it? So you're more proactive about it is like, so let's say you have something in your API that someone is trying to abuse through a sophisticated business logic kind of thing. And it could be fraud, for example, right? Someone is trying to create a sort of a fraudulent transaction because, your business logic in the API allows for that to a very sophisticated attacker. So once we can figure it out and we can block it, but the long-term solution to that is not for us to keep blocking it. The long-term solution is for a developer to go and fix it and fix their code, right? So that becomes the more proactive approach around that, right? So what we do is that we'll bring that learning from like, this is what this particular APIs have been potentially abused by this many users in these many different ways. And this is where the underlying root cause of is, let's go and let's give it to a developer to go ahead and fix it. So that's become sort of the more progressive element of it. And then eventually you want to put this in a continuous loop, where it's all of this is integrated in your CI/CD process. You're finding things, and then you go in production, you find things. And if you find some attack or something happening, we can give it back to the developers to kind of fix it. And then, it goes through a CI/CD process again. And that's kind of how we see the progression of how a product like ours or a platform like ours could be used.
As the next decade unfolds and organizations are even more digital in more ways, it strikes me that you're not just out to protect every line of code, but you're actually out there to protect every process of business. So is this extensible in your thinking when you push this out several years? Where do those use cases progress to when it comes to things like business processes and even performance optimization? Is this something that moves from a code benefit to a business benefit?
Yes, definitely. And we think about it, and we look at like the underlying model that we are building out, that we understand every line of code, how is it being used. We understand every single sort of the interaction between different pieces of code through APIs. And we understand the developer intent around those. Like, how did developers intend these APIs and that piece of code to work? and then we can figure out anything abnormal around it, right? So that we are using it to secure these APIs and pieces of code. But we can also use a lot of that knowledge to figure out like if the APIs are not performing in the right kind of way, there are bottlenecks around performance and scalability. We can help you with that. If the APIs are not achieving the business outcomes they're supposed to achieve, right? You build some different pieces of code, and they interact through different APIs, and in the end you want to have a business process of like someone applying for a credit card, and that business process is not giving the right outcome. It's maybe not accurate enough or not fast enough or not achieving the right business outcome. We can understand that as well. And we can help you diagnose and figure out the root cause of that also. So definitely we think of like eventually in the long term, like Traceable to be a platform that understands every single line of code in your application, that what is happening. It understands the intent and normal behavior of that every single line of code. And it understands every time there is something anomalous or wrong or different about it, and use that to give you full understanding around different use cases over time.
So the lesson here, of course, is to know yourself and let the machines do what they do best. It sounds like getting the horizontal capability of analyzing and creating models is something you should be doing sooner rather than later. And that if you do it, it's the gift that keeps giving, that there's more opportunities to use those insights for even larger levels of value. So it certainly seems like a virtuous adoption cycle of some kind.
I would agree. And, it really unlocks this fear of moving fast, giving your developers freedom to move fast, for them to kind of break things into smaller components of microservices and to expose through APIs. Because if you have this kind of a security safety net and kind of this insight net from, which could go beyond security to performance and business insights and everything, it reduces the fear because now you understand what will happen. We see it again and again, like, people are that, if we moved from 5 monolithic services to 200 microservices, but now we don't understand what is going on. Like you have 200 microservices, which is great because now we have so much velocity. Every dev team can move independently. They can move fast. We are moving 10x faster than we used to, but we just don't understand what's going on because there are 200 moving parts now. And that's just for microservices. When people start thinking of, serverless or functions or Lambda and technologies like these, now the approach and idea there is you take those 200 microservices and you break them into 2,000 micro functions, and these functions all interact with each other and you can ship them independently. And every function is maybe just a few hundred lines of code at most, right? So now how do you understand the 2,000 moving parts? There is a massive advantage of velocity and reusability and all sort of things that comes with it. But it's you have a challenge in managing it, right? So if you have a layer that can understand and reduces that fear of control when you have more moving parts and higher velocity, it just unlocks so much innovation and it creates such a huge advantage for any software engineering organization.
Well, I'm afraid we'll have to leave it there. You've been listening to a sponsored BriefingsDirect discussion on how today's businesses may have given short shrift to the cybersecurity vulnerabilities inherent in the expanding use of APIs. And we've learned about the latest innovations for making those APIs more trusted, understood, and robust. And so a big thank you to our guest. We've been here with Jyoti Bansal, Chief Executive Officer and co-founder at Traceable AI. Thank you so much, Jyoti.
Thank you, Dana.
And a big thank you as well to our audience for joining this BriefingsDirect API resiliency discussion. I'm Dana Gardner, Principal Analyst at Interarbor Solutions, your host throughout this series of Traceable AI-sponsored BriefingsDirect interviews. Stay tuned for our next podcast in this series with a deep dive look at Sanjay Nagaraj, co-founder and CTO at Traceable AI, as we discuss ways that APIs can be made safer and better managed. Thanks again for listening. Please pass this along to your business community and do come back for our next chapter.